Fifth grade lesson 7.9 is multiplying mixed numbers. Our essential question is, how can you multiply mixed numbers? They're going to show us two ways. Probably this is the way you're going to use regularly because you don't want to be having to always for the rest of your life draw models, but the models are really nice for your brain to understand what is happening, and that's important too. 1/3 of a 1 1/4 acre park has been reserved as a dog park. Find the number of acres that are used as a dog park. When we see of a, we know we've got some multiplication going on. We have 1/3. They wrote it as a word, and we have to recognize when that word is a number as well. 1/3 of a, that's multiply, 1 1/4 acre park. Okay. Is the area of the dog park less than or greater than the area of the 1 1/4 acre park? Remember, we started with this amount. This is the size of the park. 1/3 of it, remember when from the previous lesson, when we multiply by a fraction, we end up cutting it down. So it is going to be smaller than the original amount, than the 1 1/4 acre. So when we get our answer, we'll know if it's reasonable if it is smaller than 1 1/4. So that we can shade the model to represent the whole park. If this is 1 acre and then we have 1/4 of another acre, let's shade that in. 1 1/4. And now we need to shade the model again to represent the part of the park that is the dog park. It's 1/3 of it, right? Okay, so let's go ahead and cut these into thirds. Well, I guess I should cut all the way across. There we go. Now it's cut into third. Of that third, that's what the dog park is. And now you see we are cut, each of these holes are cut into 4, 8, 12 equal pieces. This is also 12 equal pieces. Out of the 12 equal pieces that it's cut into, how many are highlighted pink? 1, 2, 3, 4, 5. 5 out of the 12. Here, I forgot to put this here, 1 1/4. Then we shaded it. The dog park is 1/3 of it. I got ahead of myself. Draw horizontal lines. We did that. How many parts does each rectangle show? 12. What fraction of each rectangle is shaded twice? 5. Oh, well, of each rectangle, they said 4 and 1. That's this 4 here and 1 here. 4 plus 1 is 5. I just start going, and I get all excited about the math, and I forget to fill things in. So 5 out of 12, 5 out of the 12 pieces there has been set aside, 5/12. Proper fraction, right? So it's less than 1, it's less than 1 1/4. So we knew it was going to be smaller, and that makes sense. Okay, that's what's happening for the model purposes of it, for you to view. Now, this is going to take us back to, remember when I showed you the steps for multiplying your fractions, and I had put as the first step, in fact, I'm going to write those steps down. We were changing everything to a fraction, and then we would cross-reduce our fraction. You'll see that again if you're shady on that, because it's been a few days. I'll review that with you. You multiply it straight across, the numerator and the denominator straight across, and then if it's improper fraction, or a fraction more than 1 on the answer, on the product, then you convert it back into a mixed number. If it can be reduced, then you reduce it. So these are the steps we're going to go back to, and we didn't really have to do much of this when we were learning that earlier, but now you'll see we have to do more, change to fraction. So we write the mixed number as a fraction greater than 1, an improper fraction. Remember I talked about that like being an upside down snowman, where the large number was on top of the small number, like the snowman is upside down. That happens when a fraction is larger than 1. So you'd have a mixed number there. So we have these mixed numbers right here, and we want to convert it into a mixed number. We've talked about this before, where you multiply this and add that. 1 times 4 is 4, plus 1 is 5. So I end up with 5/4. When it's upside down like that, when it's improper fraction, or a fraction greater than 1, we know that it really is 1 1/4. This is just another way to write it. Okay, that is this step. Change it to a fraction. So if you see a mixed number, you do that. Why am I doing this? Just as a quick review, why does that work? That multiply this and then add that. This is one pizza that's not being cut up, and this is 1/4 of the pizza that is cut up. And I have all of this, right? What I'm going to do is I'm going to cut this one that's not cut up. That's where the 1 times 4 comes from. Now I have one pizza cut into 4 slices. I have 4 slices. 1 times 4 is 4. I have 4 slices. Then I add it to the one that's already here. So these 4 pieces plus this one. 1 times 4 is 4 plus 1 is 5. 5 fours. I'm going to do a quick one real quick here. 2 and 2/5, let's say. That is like having 2 pizzas and then another pizza cut into 5 equal pieces with 2 of those slices there. To change that to an improper fraction or a fraction greater than 1, I multiply this and I add that. I'll do that part. 2 times 5 is 10 plus 2 is 12, and I should get 12/5. Your denominator always stays the same with that. Here's why. I need your brain to understand why. I am saying I have these 2 whole pizzas. I'm going to cut them into 5 slices. So if I cut them into 5 slices, how many slices do I have now? I have 10, 5 and 10, right? 2 times 5 is 10. That's what this multiply step is doing. It's just saying, oh, I'll cut these up now. How many slices do I have? 10. Then I add it to the 2 slices I already had here. So multiply, add, this is how many slices. That's why that works. Okay, back to this. We changed to a fraction. We check for cross reduction if it's possible, but there's nothing that divides evenly into 3 and 5 other than 1, so I can't reduce there. And there's nothing that divides evenly into both 1 and 4 other than 1, so I can't reduce there. Next step, multiply straight across my numerators and my denominators. 1 times, that's a 5. 1 times 5 is 5. 3 times 4 is 12. And so my answer is 5/12, which is what we got from the model. And I know sometimes people get frustrated with the model part of things, but it is telling our brains what is happening so that it can better accept the steps that you're taking once you start doing the calculations, and it helps you understand how you solve a problem and if the answer is reasonable in the end. So it's worth the time. I know it sometimes feels frustrating on the modeling. At least for me it does. The modeling of fractions sometimes confuses even me, but in the end I appreciate that my brain understands it better. Okay, let me put the steps down again. And we have, here's our steps now. We have 12 times 2 and 1/6. They want us to write the product in simplest form. That's our step 4. If it's reducible, we will reduce it. Determine how the product will compare to the greater factor. Okay, before we do the multiplication, these steps, it's from the previous lesson. How is it going to compare to the greater factor? 12 is the greater factor. 12 is large. And we're multiplying it by 2 and then some, 2 and a little more. So it's going to be larger, right? We've got 12 twice over and then a little bit more than that. So it will be larger than 12. Oops, I need a pen there. Hold on. Larger. Write the whole number and mixed number as fractions. Okay, remember this is that first step. Change everything to a fraction. Remember how we change a whole number into a fraction? We just put a 1 under it because 12 divided by 1 is still 12. So we haven't changed the number at all. We've just made it fraction so that we can work with it. Now we've got to change this one to a fraction. 2 whole pizzas cut into 6 slices is going to give me 12 slices, right? 2 times 6 is 12. Plus the 1 slice that was already there, that is 13. I'll do that again. 2 times 6 is 12, plus 1 is 13. The denominator, of course, stays the same. Now, they have us going ahead and multiplying here and then reducing afterwards, and they're skipping this step. I'm going to do it both ways so that you can see the cross reduction, and then you'll see exactly why I go ahead with this step. I'm going to do 12 times 13. I'm going to go to multiply straight across. 12 times 13, I need to calculate. 12 times 13. 3 times 2 is 6. 3 times 1 is 3. Cross off. 1 times 2 is 2. 1 times 1 is 1. And I get 156. Then I multiply my denominators. 1 times 6 is 6. Okay, I can reduce that now. And I'm not sure what the largest number that divides evenly into both of these is. However, I do know that 2 goes into them because they're both even. So I'll start by dividing by 2. 156, oopsie, 156 divided by 2 is going to give me 7, will give me 14 and 8. So 78 thirds. 6 divided by 2 is 3. I think 3 can go into 78. So I'll divide one more time. Twice there, and 6, 12, 18, 6 there. So it's 26 over 1, or 26. All that reduction, kind of a lot, right, with those big numbers. And I'm not sure, once the numbers get high, I'm just not sure all of the factors or what the largest factor that goes into it can be, so I have to do it twice sometimes. Watch what happens when we take care of that cross reduction step. And back up to this one. I'm going to check for cross reduction. Well, nothing goes into both 1 and 13, so I can't cross reduce there. But here I can, because 6 goes into 6 once and 6 goes into 12 twice. So let me do that. Let me reduce there instead. Oops, that's once. 6 goes into 6 one time, and 6 goes into 12 two times. And now I will multiply straight across, now that I've cross-reduced. 13 times 2 is 26. 1 times 1 is 1. And I ended up here anyway. But I didn't have to do reduction with 156. So that's why I like the cross-reduce step, because it can help me with the smaller numbers. I can reduce faster if those numbers are smaller. Then I don't have all this mess going on. Anyway, after all that, our answer is 26, which we knew was going to be larger than the 12, right? Okay. Example 2, we can use the distributive property if we want to. We can multiply 6 times 4 and 1/8 and write the product in simplest form. 4 and 1/8 can also be written as 4 and 1/8, 4 plus 1/8. Then I can do the 16 times 4 and the 16 times 1/8 if I want to do it that way. 16 times 4 is 24, 4, 5, 6, 64. Plus 16 times 1/8 is 16 eighths. 16 divided by 8 is 2. So that's where they got that 2 from. And then this gives me 66. So that's another way I can do this sort of calculation, as I can pull that number apart. I have a feeling you'll find that as you get used to these steps, the more you do them, the more stuck in your head they get. As you get used to these steps, you'll just real quickly be able to do those. They say to explain why you might choose to use the distributive property to solve example 2. I mean, you've got some pretty large numbers, 16 and then the 4, and those numbers grow quickly. So maybe because they're larger numbers, maybe because it's a 1/8, a single unit. I don't know, maybe you just like that better. I'm not really sure the answer they're looking for there. Maybe that's a process that makes sense to some people better, or maybe because it's larger numbers. I'm just going to put larger numbers. I don't know why somebody would choose that way. Everybody thinks differently. So for some people, they're going to say, oh, I'd rather this. And some people are going to say, I'd just rather that. When you multiply two factors greater than 1, is the product less than, between, or greater than the two factors? If our two factors are larger than 1, we are making those bigger and bigger, so they will be larger. Okay, here's where everything starts clicking into place. So if you're still feeling a little hazy and unsure, don't worry, that's okay. Let's go ahead and let things click into place here. We're multiplying 1 2/3 times 3 4/5. This is a whole number 1 and some more, and 3 and some more. So we know our number is going to be bigger than our largest factor, 3. So it'll be 4 or 5 or something bigger. Let's change these to fractions. We're going to do that multiply add thing. Because we have one pizza, we're going to cut it into 3 slices, and that's going to give us 3 slices. 1 times 3 is 3, plus 2 more that were already there is 5. The denominator stays the same, 5/3. Then we have 3 times 5 is 15, plus 4 more, 16, 17, 18, 19. Okay. Now we're going to multiply straight across. Actually, I'm going to cross reduce first before I go to here, because I noticed right here, 3 and 19, there's nothing I can do about that. But 5 and 5 I can, because 5 divides evenly into both of these numbers. So I'm going to go ahead and divide those evenly into both of those numbers. 5 divided by 5 is 1. 5 divided by 5 is 1. And now multiply straight across. 1 times 19 is 19. And 3 times 1 is 1. I'm sorry, 3. 19/3 is our answer. But we need to convert that right? It's improper fraction or a fraction greater than 1. So we're going to convert that back into a mixed number. We know it's going to be somewhere above a 3. So we're doing 19 divided by 3. 19 divided by 3. 3 times 6 gives me 18 with 1 left over out of the 3 that we divided. 6 and 1/3 is our final answer. I know it's a lot of steps. I know that it's going to take a little bit. Just be patient with yourself. You're okay. If you're still not sure, you're doing fine. Just keep it up. Stay with me. Stay with me. We got this. Okay, we're going to change everything to a fraction here. 1 times 8 is 8, plus 1 is 9. That is going to give us 9/8. Now we have 2 times 3 is 6, plus 1 is 7. That is 7/3. And of course we had a whole number here and a whole number here, so we're going to be a little bigger than our biggest factor here. So it's going to be 2 and a little more than 1/3, or maybe even up to 3. We'll find out. Let's check for cross reduction now. That's our next step. 7 and 8, there's nothing other than 1 that divides evenly into 7 and 8. As you get your math facts memorized, this becomes easier and easier, this reduction part. 3 and 9, 3 divides into 3, and 3 divides into 9, so that's what I'm going to do. 3 divides into 3 1 time, and 3 divides into 9 3 times. And now I can go down to my multiply step. 3 times 7 is 21. And 8 times 1 is 8. This is an improper fraction with the large number on top of the small number. That means it's a larger than 1 number, larger than 1 number. So I need to convert it. I do that by doing the division like I did over here. 21 divided by 8. 21 divided by 8. 8 times 2 is 16. 8 times 3 is 24, so that's too big. So it's going to be 8 times 2, which is 16. That leaves me with 4 8s left over. 2 and 4 8s. Notice this 4 8s, both of those are even. In fact, 4 can go into 4 and also into 8, so that's what I'm dividing out of it. Same idea as the reduction on the cross reduction. It works the same way, your factors. As long as you're doing the same to the numerators you are the denominator on this, it's still the same fraction, just cut differently. 4 divided by 4 is 1. 8 divided by 4 is 2. So my final answer is 2 and 1/2. So we had to convert here, and then also still had to reduce afterwards. So even when we cross reduce, it doesn't always reduce us all the way down. Sometimes there's still reduction that has to be done, but there's less chance of having to if you get the cross reduction early. Okay, we have 3/4 times 6 and 5/6. Step 1. Let's just do 1 bite at a time, right? We're not going to put the whole waffle in our mouth and not be able to chew it up. Change everything to a fraction. This already is a fraction, so yay for me. By the way, this is a whole number 6 and 5/6. That's our largest factor, and it's being multiplied by a number less than 1. So we're going to get a number less than 6 and 5/6. So because we're cutting it down now. Change everything to a fraction. That's a fraction. This becomes a fraction by doing 6 times 6 is 36, plus 5, 37, 38, 39, 40, 41. So we're doing 3/4 times 41/6. Ooh, that's some pretty large numbers. I hope we can cross reduce. I can here because 3 divides evenly into both 3 and also into 6. 3 will divide evenly into 3 just the one time, and into 6 2 times. I don't think 4 and 41 have any common divisors, so that's it. Now I'll do the multiply straight across, numerator, denominator. 1 times 41 is 41. 4 times 2 is 8. We now have an improper fraction, a fraction greater than 1, so we'll convert it into a mixed number by dividing 41 divided by 8. Some scratch paper is probably good to have around. 41 divided by 8. 8 times 5 is 40. Again, knowing those multiplication facts really helps, doesn't it? Keep working on those. Make sure you get them memorized if they're not already. And I ended up with 1 as my remainder, becomes my numerator. 8 divisor stays my denominator. 5 and 1/8. I'm going to buy myself a little more room and put this to another slide for number 4 and number 5. They said on this they want us to use the distributive property. That was where we pull things apart and put things together again, like the Humpty Dumpty sort of thing. So we have 2 and 1/2. That's the same as 2 plus 1/2. And we can multiply the 16 by both of those pieces. So we can say 16 times the 2 can be added together with 16 times the 1/2. 16 times 2 is 32. 16 times 1/2, this is 1/2 of 16. What is 1/2 of 16? Yeah, it's 8. And 32 plus 8 is 40. So that's how we could do that one. So there's the distributive property. It's kind of nice that way. It's easy if you've got a half times a whole number, especially if it's half times an even number, because cutting things in half is easy on an even number. Same here, let's do 1 4/5. We're going to do 1 plus 4/5 to pull it apart Humpty Dumpty style. Then we're going to multiply 15 times both of those, 15 times 1, and then we will add that to 15 times 4/5. 15 times 1 is 15. 15 times 4/5, I'm going to use my steps, change to fraction. You saw me do that right away. I changed to fraction. Then I'll cross reduce because 5 goes into both of these, so that's easy enough. 5 goes into 5 once, and 5 goes into 15 3 times. Then I'll multiply straight across. 3 times 4 is 12. 1 times 1 is 1. That's the same as 12. Then I can simply add those together. That's going to be 27. So that's how you could use the distributive property. If that is more comfortable for you, you can do that way. And that's all the share and show ones. If that all makes sense to you and you have a preference on whether you're using distributive or whether you're using those steps, then you go on ahead to your independent practice. If you feel like you could use a few more practice ones using the steps, I'll do a few more with you and you can stick around. Okay, let's look at number 6. Here's all of our steps. We have 3/4 times 1 1/2. This is the larger factor, 1 and some more. This is a fraction less than 1, so our answer is going to be smaller this time. Change everything to a fraction. This is a fraction. This is a mixed number. Let's go ahead and convert it. 1 times 2 is 2 plus 1 is 3. So we now have 3/4 times 3/2. Check for cross reduction. There's nothing that divides evenly into these two, and there's nothing that divides evenly into these two. So skip that step then. Multiply straight across. 3 times 3 is 9. 4 times 2 is 8. Now we're on convert reduce. If this is an improper fraction, and it is, or a fraction greater than 1, it is, with the big part of the snowman on top of the little part of the snowman, then we just divide 9 divided by 8 to get it back into mixed number format. 8 only goes into 9 once, with 1 out of the 8 left over, and it is smaller, little bit smaller. 1/2 of a pizza is more than 1/8 of a pizza. If you have to share with 2 people, you get a bigger slice than if you have to share with 8 people. So it's a little bit smaller as we expected. All right, let's take a look at this one. 4 2/5 is multiplied by 1 1/2, 1 and a little more. This is our large factor. It's being multiplied by a number larger than 1, just a little bit larger than 1. So our product will be a little larger than our large factor. Let's go ahead and change everything to a fraction. 4 times 5 is 20, plus 2 is 22. Denominator stays the same. 1 times 2 is 2, plus 1 is 3. Denominator stays the same. Check for any cross reduction if it's possible. Here it's not. Nothing goes into both of those other than 1. Here it is. 2 divides evenly into both of these. That's nice. Let's divide 2 into both of those. 2 goes into 2 once, and 2 goes into 22 11 times. That makes that a much smaller number to work with. Multiply straight across. 11 times 3 is 33. 5 times 1 is 5. Convert. This is an improper fraction or a fraction greater than 1. Do 33 divided by 5 to put it back into mixed number. You'll get really fast at putting those back and forth, I promise. Just practice will make the difference. 5 times 6 is 30. That's as close to 33 as I can get, with 3 out of the 5 left over, 6 3/5. I hope those 2 practice ones helped a little bit more. And trust yourself, be patient with yourself. In time, you'll get better and better, and don't be upset with yourself if you make errors. That's part of learning.